What will transportation look like in the city of the future? One thing we can be sure of, it will be different. Because our cities are facing four major crises: climate, traffic, health, and inequality. I believe we can not only respond to all of them, but also provide a better transportation system that people will want to use. But first, why and what exactly needs to change? The climate crisis is the most dangerous, as it threatens our long-term survival on this planet. We must reduce the greenhouse gases and other pollutants poisoning our Earth. Not only the greenhouse gases generated from burning fossil fuels to operate cars and trucks, but also the embedded greenhouse gases that come from oil well drilling and refining, manufacturing and maintaining cars and trucks, and building and maintaining roads, bridges, and parking spaces. Simultaneously, we must keep transportation going while under assault from higher temperatures, forest fires, storms, and flooding. High temperatures can melt tarmac, expand metal, crack bridges, and make city life unbearable. Storms can make roads impassable, trigger flooding, and short out traffic signals. All major cities have a traffic crisis. As cities grow, travel distances increase. Direct routes become overcrowded. Roads and parking consume more and more precious space, currently 30 to 50%. In particular, more roads mean more intersections, more stop-and-go traffic, longer and longer travel times. How much of your life have you wasted stuck in traffic? Also, roads become more dangerous as vehicles compete for road space and try to make up time. This is particularly dangerous to pedestrians, cyclists, and children. Transportation is currently a significant contributor to air pollution from diesel and gas fumes and tire and road particles. Areas close to busy roads are not healthy places to live. Also, epidemics are becoming more frequent as global trade and international travel increase. People need space for social distancing. In particular, crowded shared public transportation is a health risk. The cost of transportation is a significant burden on our city and citizens. Many people cannot afford to own and maintain a vehicle. Many U.S. cities have no public transportation or systems that are slow and unreliable. Without a ride, it is tough to find work. Many cities cannot afford to maintain their roads and bridges properly, let alone fund changes to improve traffic flow. Some places have to resurface their roads every 2 to 3 years. So the why and the what can be summarized as follows. We need a transportation system that is faster, safer, cleaner, greener, affordable, and more flexible. We can meet all of these requirements, and I will explain how. But first, a quick look at some other options and why, although they will help, they do not offer a complete solution. During the pandemic, many people have worked from home, and this may continue after it's over. If so, this will reduce the need for transportation. But it depends on transportation to deliver food and supplies, and the vast majority of jobs still require people to work on site. Also, many people do not want to live in a virtual world. A recent Stanford University study found that half would prefer to return to work. Electric cars will reduce operating greenhouse gases if and only if the electricity is generated from renewable sources, solar or wind. But they will increase embedded greenhouse gases. Countries will need to expand their electrical supply and distribution systems and build thousands of recharging stations. They are heavier than fossil fuel cars because of the batteries, which means more tire and road wear, and is why they need so much electricity. Mining and refining rare earth materials for batteries will also have a considerable environmental impact. And electric cars will do nothing to improve the traffic crisis. Subway trains could help, but digging tunnels is extremely expensive and takes a long time. The new Elizabeth line in London cost $23 billion and is taking over 13 years. Many cities are close to the ocean or major rivers, and with climate change, they face an increased risk of flooding. Also, people are crowded together, particularly during the rush hour, which is bad for public health. The most fanciful idea is flying vehicles, helicopters, drones, and jetpacks. The idea of flying point to point above the city is very attractive, and electric flying vehicles are possible. However, I do not believe flying vehicles will ever be practical for city travel except for the super rich. Flying vehicles require a lot of energy solely to stay up in the air. They are vulnerable to wind and the downdraft from other vehicles. Air traffic control is complicated and only works at airports because the planes fly in circles waiting for their turn to land. Also, flying vehicles represent a considerable safety risk to people below. A 20-pound package is the same weight as a large cannonball. I believe our best hope for the future is an advanced form of cable transportation. There are numerous commercially successful point-to-point cable car systems in the US, and even more in Europe, China, Asia, and South America. Cable transportation systems offer the benefits of aerial transportation, faster and more direct routes, without the need to build more roads. But the cables provide two significant benefits. They support the weight of the vehicle, eliminating the need to burn energy to stay aloft, and they control the direction of the vehicle, avoiding the need for active steering to avoid obstacles. Cable transportation is inherently more efficient and safer. Indeed, they are famous for continuing to operate in bad weather when roads are impassable. So how could this simple idea evolve into a practical transportation system for an entire city? I'm excited to share the vision of how to do this. In a cable system, the cables are the roads. Strong cables several miles long are already available, and cable technology is so advanced today that companies are seriously trying to make a space elevator 22,000 miles into space. Note, the cables on this slide are not to scale. A 2-inch cable would be nearly invisible at that height. The high-rise buildings provide the height and mass to support the cables and the stations that serve as both transit terminals and intersections. But the station only requires a few floors. The vast majority of the floors support other uses: houses, offices, shopping malls, medical and civic centers. So the station is only a small part of the total building cost. Having a station in a building could significantly benefit any commercial business in that structure. A city center may be able to convert some existing buildings to support a station, but the suburbs will probably need to build whole new structures. This should become part of the plan for any new suburb. But note, such a system has a minimal surface footprint, which is the highest cost when building roads. And the cables will over time be much less expensive to build and maintain than roads. The cable stations operate as transit terminals and intersections. In the departure lounge, passengers get into a cable car and request a destination. The station then schedules their trip. In the switching area, cable cars arrive from the departure lounge or an incoming cable, and the station switches them over to the correct outgoing cable or to the arrival lounge at the end of a trip. In the arrival lounge, passengers get out of the car and leave. The station decides where the car goes next. It may be sent back for another passenger or to the parking area to recharge. In the parking area, cable cars are stored and automatically recharged as necessary. The cable cars carry a single passenger with luggage or a parent and small children, as shown. This avoids the time delays and health risks involved in sharing a larger vehicle with other passengers. The cars have a lightweight body for protection from the weather and are streamlined to minimize wind resistance. The wheels grip the cable securely, are contoured to provide traction, and are powered by small electric motors to provide a fast and comfortable ride. The electric drives use regenerative braking to minimize the need for electricity, similar to high-end electric bicycles. The cars are fully self-driving, steering and speed control. The passenger only has to define their destination. The cars are designed for mass production and will cost much less than any existing automobile to build and maintain, since they are smaller and have fewer parts. They also consume much less electricity than any electric automobile, since they are so much lighter. To provide transportation to an entire city requires a network of cables and stations, maybe a mile apart. Each cable operates as a single high-speed traffic lane. More cables can be added between any two stations to support a greater traffic flow. The stations manage departures and arrivals and the automatic transfer of cars between cables. A city with a complete network can provide close to direct routing for most journeys. See the green lines. The dotted line is the ideal direct path, and the solid line is the actual path. More direct routes and much fewer intersections will significantly reduce travel times. The cable cars control their speed precisely to ensure a safe, maybe 2-second, separation between vehicles and make cable travel times predictable. A passenger selects a destination and the system automatically assigns the best route. Note in this example, this involves 4 cables. The system schedules trips as follows. It allocates cable time slots to eliminate conflict and ensure a smooth flow of cars. The critical point is not to start a journey that cannot be finished without stopping. So cars traverse a series of cables at consecutive reserved time slots. Note in this example, the blue time slots are already reserved, so the green arrow shows the first available complete journey. When reserved for this trip, the departure and travel time are set. The system also manages car availability, return routing them as needed, so most cars will complete several trips per day. Most automobiles carry only one driver, so we will need far fewer cable cars and parking spaces. In conclusion, cable transportation will be faster by completing a 10-mile commute in 10 minutes or 15 in 15, etc., at any time of the day or night. Safer for passengers and bystanders, and significantly reduce the 38,000 fatal crashes per year in the US. Cleaner by eliminating air pollution from fossil fuels and tire and road particles, and improve public health by supporting social distancing when needed. Greener by using less than 1/10 of the electricity needed to operate an electric car, and reduce the embedded greenhouse gases required to build and maintain roads. Affordable by providing transportation any citizen can afford to use and any city can afford to build and maintain. Flexible enough to expand as a city grows or be modified as traffic patterns change. In the US, transportation is a lifestyle choice. I believe this will provide better transportation that most people will want to use. A city will need to retain some roads for heavy construction equipment and multi-passenger and emergency vehicles. But cable transport will liberate most of the city surface for people, bikes, trees, and parks. How we use that space determines the quality of life in that city. Shade trees can reduce the temperature of a sidewalk or park by 10 degrees. This may be a life-saving difference as the planet warms. Public transit implies walking to a station, a half-mile walk at each end if the stations are a mile apart. Not a hardship if safe paths are available. Walking is an excellent way to incorporate regular physical activity into the day and has significant health benefits. For the less energetic, electric bikes or scooters can help. Indeed, for short trips, these micro-mobility options may be entirely sufficient. In conclusion, I believe cable transportation will transform city life.